Okay, so here we go. 1.2. Okay, so 1.2. So we have the topology, right? And then some parameters are given. So V0 equal to 12 volt, and then we also have Vin is equal to 20 volt. Okay, and we also have the information, very important information. Switching frequency is equal to 200 kilohertz. Okay, and then the questions ask us to calculate dA and T-out, right? Okay, so once we see this kind of information, actually we can calculate the TS immediately with the very simple relationship. So TS is the reciprocal of the Fs, right? Switching frequency, and this one is the switching interval, and so we can have this 5 microseconds, right? Okay, and then here. Okay, so actually very simple. We can derive our the equations on our own, or even use the equation given in the slides. Okay, so that equation should one of the equations should be equation 1.4. Okay, and this one gives us the dA equation. So later, I think from in topic 3, you will know how it comes. Okay, you will know. Or actually, just before, right? Actually, I have told you how it comes, but later will be in detail. Okay, and then substitute the parameters in. This is 12, and this is 20, and this is equal to 0.6. Okay, and then the other one is equation 1.3. Okay, and T-out is equal to, it is because dA from the definition is the ratio of T-out and Ts. Okay, and then substitute these parameters here, 6 and then 5 microseconds. So it will give us 3 microseconds. Okay, and then the most important thing is that how we can draw or plot the waveform. Okay, so this is very important. Okay, so let me use the other color. Okay, so here we need to first we know that T-out is 3 microseconds and the whole switching interval is 5 microseconds, right? So here actually we can do something like this: 3 microseconds and then 2 microseconds. Repeat the other interval, 3 microseconds. It is not in scale. Okay, I just draft. Okay, something like that. Okay, so this is the time with the unit of microsecond. Okay, so here I just 3, 5, 8, and 10. Okay, it is because we just calculate, right? So T-out is equal to 3 microseconds. T-out is 3 microseconds, and then the Ts is equal to 5 microseconds. Okay, so this is 5, and this is one cycle, and then the other cycle started here. Okay. Okay, so so the first thing, draw the wave, plot the template. Okay, so QA, VA, and then with the clear label of the x-axis and unit. Okay, and this one, of course, we also have the unit. Oh, and QA has no unit, either 0 or 1. Okay. Okay, so I may use the other color. Okay, so during T-up, QA is equal to 1. During the remaining period, QA is equal to 0, and then repeat the waveforms. Okay, and then connect them together. So this is the QA waveform. Very, very simple. But it is also very important to start with. It is because it will help you to fix the time frame or timeline. Okay, so for example here TL is 3 microseconds and TS is 5 microseconds. Okay, and then VA. So VA here is also very simple. It is because from the topology we know that when QA is equal to 1, VA is equal to V in, right? Okay, so VA is equal to V in. Otherwise, VA is equal to 0. Okay, so we just need to draw along what we analyzed. Okay, okay, and then connect it together. Okay, and this is 0. Okay, and then this is VA when QA is equal to 1. VA is equal to V in, right? Okay, so V in here is V in here is 20 volt. Okay, so 20 volt. So we need to label here 20 volt. Okay, and then of course this is the output, right? So we need to draw the dashed line to represent the average value. And the average value, according to the topology, it should be equal to V naught. Okay, and V naught is equal to 12 volt. Okay, 12 volt. So 12 volt. So that's it. So this is our solution. Okay, this is our solution. And now I'm going to tell you what how I count your or how I grade your waveform. Okay, I may change the color green. Okay, yeah, maybe. Okay, yeah. So I will use the deduction method. So once again, this is my approach. Not represent the approach of Dr. Yang. Okay, so Dr. Yang may tell you guys about his style. Okay, so here we go. So for example, this one I will use I will use the deduction method. So what is the deduction method? So for example, this one I will say give 5 marks for this waveform and 3 marks for this waveform, and then how it counts. So you need to indicate the label 1, 2, 3, 4, yeah, and 5. Okay, or 6. Okay, 6. Okay, so this one full mark is 6. Okay, and for this one, one here, the waveform should be correct, and then the average, so 3. Okay, so if you miss one of them, so for example, if you have, let me change the other color, apple. Okay. Okay, so if you didn't mention this, and then you have 4. If you didn't count this one, didn't label this one, or you instead you just give me say V in here, and then you will, if your waveform is correct, and then you will have 1 mark. Is that clear? Okay, so I will use this approach to grade your waveforms. So please indicate the critical points. So what are the critical points? So these are the critical points, right? So without those information, this only a lie without giving any meaning, right? And here also, if you just give me this parameter, Actually, I don't know, I may be nervous during the exam or a test. Some students really cannot uh, refer to the correct value given in the problem. Okay, so please try to give me the value, not the parameters or symbol. Okay, so once again, I will use the deduction method to grade your waveforms. Okay, so in most cases, I will not observe or check your calculations. I just mark the waveforms. Okay, just mark the waveforms. So try to, yeah, of course, give me the correct waveform. And the most important thing, I think the major reason why some of the students got failed at the end, it is because they just memorize the shape of the waveform. Okay, so in most answers, they just give me something like that. Something like that. That's real case. Okay, so for this one, I can only give you 1 mark, although without any meaning, right? So no indication of the timeline, no indication of the magnitude of the output. Okay, so I will still give you 1 mark for this one, but it is far below the passing mark. Okay, so for example here, um, 2 waveforms give you 9 marks. Okay, but if you give me this kind of answer for each waveform, you can only have 2, right? So half mark is 4.5. So you only have 2. So at the end you should fail. Okay, so hopefully you can get what I mean. So do you have any question? Any?